What's going on, guys? It's Invalid here. I record stuff on YouTube, chat description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called remove invalid parentheses. Remove the minimum number of invalid parentheses in order to make the input string valid. Return all possible results. Note, the input string may contain letters other than the parentheses, an open one and close one. Well, let's look at those examples real quick. We got this string right here, we get rid of these parentheses and we return this result. We get rid of this one and return this result. Here we get rid of this one, return this result, get rid of this one, return this result. Here, get rid of those parentheses and return an empty string. Well, we can keep track of the bounds of those parentheses in a string using stack. Stack data structure means last in, first out. We push the elements onto the top of the stack and then we can pop the elements from the top of the stack. That's how that works. We can do better though. We can create a counter, and every time we see an open parenthesis we increment the counter by 1. Every time we see a closed parenthesis we decrement the counter by 1. For example, we're gonna have a string right here. You can see that 1 open parenthesis and 2 close parenthesis. The counter right here, 1, then 0 and -1. This string is invalid. Okay, the counter is negative. For example, we're gonna have more open parentheses than closed ones, so we increment the counter by 1. As I said right at the bat, every time we see an open parenthesis and decrement the counter by 1 every time we see a closed one. Okay, so we got 1. The counter is equal to 1. This string is also invalid. In the case when the number of both open and closed parentheses is the same, right, is equal, we say that this string is valid. The counter is equal to 0. Okay, in this solution I'm gonna show you we will be getting rid of the first parenthesis in a series of consecutive ones. For example, right here we get rid of the first parenthesis right here in a series of consecutive ones, and we keep track of the last removal position because we would like to overcome generating I would say duplicate, because you know we could get rid of the parentheses again. For example, in this case a closed parenthesis that is in a different order. That's why we need to keep track of the last removal position. Yeah, so go for it. I'll tell you how to do that. First we create the list. List, the type string, it's called list, new array, list of the type string. we need a helper method. It's called remove. We pass s, then the list, the last removable positions of I and j respectively, 0 and 0, and the pair of parentheses, new char array, and those parentheses right there, an open one and close one. Finally, we will return already modified list. Return list. Here we implement remove the helper method. We say string s, then list type string list, int last I, int last j, right here p means pair. We create the for loop, int k, a variable k means the counter is equal to 0 initially, then I is equal to last I is less than s dot length, the length of that string, I plus plus, and at each iteration we check. In the case when the character at the position of I, the current position, in S is equal to the parenthesis, which is at the position of 0. For example, right here we can see that right to the bed we pass an open one and then a closed one. At the position of 0 we get open one, so we increment the counter by 1. In the case when the character is equal to p1, means that for example right here the parenthesis is closed, we decrement the counter by 1. In the case when the counter is greater than or equal to 0, we go on iterating. We continue. Next, in the case when the prefix is not valid, isn't valid, we create a for loop, and here we create a variable j is equal to last I last j, j is less than or equal to I j plus plus, and we could get rid of those parentheses, there is no need, and we check in the case when the character at the position of j is equal to the parenthesis at the position of I, the position of 1, which is in this case like right at the bed, it's a closed one right here, you could see, yeah, the beginning is closed one. So also we check, we need to make sure that we are within bounds. So we say j is equal to last j, or the character at the position of j minus 1 is not equal to the parenthesis which is at the position of 1. In this case, we call remove method recursively. We pass the string s, then the list. What else? We pass. We remove. We pass. Hold up. We pass the substring. We pass the substring automatically already. Say s dot substring from the position of 0 up to j plus we pass the concatenation, then s dot substring j plus 1 and up to the length, the length of that string, the end of that string. Then list I and j, the removal positions, and p, which is the pair. Okay, this right here means that we are within, we need to make sure that we are within bounds. This right here means that we delete the first parenthesis in a pair of consecutive ones, that the character at the position j minus 1 is not equal to the parenthesis that is at the position of 1, and we right here need to find the point where the character at the position of j is equal to the parenthesis at the position of I in p. For example, we could have parentheses right here, you see, right? Like, any characters. At this point of time, okay, at this point of time, right here, we can see that this prefix is invalid. Why? Because right here the counter is equal to 1, then 0 and minus 1. The counter is negative, okay, right here. Yeah, so what we do is we find the first moment when the prefix is unbalanced. Right here, p at the position of 1, we got a closed parenthesis. Then we take the substring, means right here exclusive, up to this point, means this part, plus the concatenation, this part right here, and this part. J plus 1 right here means we are at the position of J. J plus 1 means right here, okay? And pass as S. You could, delete that. We pass this concatenation, then we pass list and the last removal positions and P, the same pair. We call, return. We could, call return, and in the case when right here, in the case we could have a valid prefix, but also we could have more open parentheses than closed ones, like this, for example, right? You can see that we can see that we have two open parentheses and one closed parenthesis. So in this case, okay, usually what we do here, we solve this problem left to right. You can solve this string right to left, but it's better you to reverse the string as reverse this string, right? For example, like reverse this string and solve this problem, this string, left to right. We say r st is equal to new string string builder dot reverse dot to string. First we reverse that string, we pass s. We reverse those characters, then we represent that sequence of those characters as a string already reversed right here. And we got two cases right here. The first one, in the case when the parenthesis at the position of 0 is open, we call remove recursively and pass already reversed string, then list the removal positions 0 and 0 and the different order of those parentheses. New char. Right here we got, instead of open, we got closed. Close one and open one. And else means that p at 0 is not equal to open. We add that already reversed string to that list. That's it. That's the whole problem. So let me check real quick. We got list, we got remove, return already modified list. We are iterating through that string s, right? the counter is greater than or equal to 0. Continue. Okay, yes, it is. Yeah, good. Let's run this code. Accepted, good. Let's submit. Success, great. So right here we just, call this method recursively and solve the rest of that string recursively. That's what we do. Yeah. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram. Add me on Snapchat. And I'll see you next time. Have a good one. Bye.